Hi, I'm Miss Hall, and this is Lesson 9, Characteristics of Quadratic Functions, Part 2. Let's review the quadratic function forms we've learned so far, starting with vertex form. So in vertex form, it is really easy to identify the vertex. Seems obvious. And then to identify the axis of symmetry, that is, of course, x equals h. The form we learned in the previous lesson, lesson 8, is standard form. And for standard form, it's, let's say, easy, or you're quickly able to identify the axis of symmetry because that is negative b over 2a. Now the vertex takes a little bit more work. The vertex, you know the x value of the vertex is negative b over 2a. And then the y value of the vertex, what we did last lesson, is we plug the x value of the vertex into the function. So I can write f of negative b over 2a. And now the new form we're learning today is intercept form of a quadratic. And intercept form has an a value. They all have an a value. And then it has two binomials. And it's called intercept form because these constants p and q represent the intercepts, the x-intercepts. P and q are the x-intercepts of the parabola. They are the x-intercepts. There is a little diagram below about this new formula, and you can see the x-intercepts are p and q. The axis of symmetry is halfway between those points, right? The axis of symmetry is equidistant between those 2 points. And so you can find it by adding p plus q over 2, dividing by 2. And then again from there, once you know where the axis of symmetry is, that value is the x of your vertex. So to find the vertex, we can have p plus q over 2 gives us the x value of the vertex. And for the y value, we'll plug in that x value into the function. So f of p plus q over 2. Okay, let me just look over this core concept. So we discussed that formula. F of p and f of q make the formula equal 0, therefore they are the x-intercepts of the graph. The axis of symmetry is halfway between those intercepts. And just like every other form, when a is greater than 0, the parabola opens up and the vertex is a minimum. And when a is less than 0, the parabola opens down and the vertex is a maximum. Example 5. The parabola shows the path of your first golf shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your second shot can be modeled by the function f of x equals negative 0.02x times x minus 80. Which shot travels farther before hitting the ground and which travels higher? So label this A and B. We've got to answer 2 questions. We have a picture of our first golf shot. Our second golf shot is modeled by the function f of x equals negative 0.02x times x minus 80. So this is an intercept form where we have an a value, right? This is the a value of negative 0.02. We have a p value of 0 and a q value of 80. If you don't see that p value of 0, we can rewrite this function as negative 0.02x times x minus 0 times x minus 80. That p and q value, right, are the x-intercepts. So p of 0 means we have here at 0, 0, 1 x-intercept. That makes sense. The golf ball starts on the ground and we hit it. And 80, 0 80, 0, where then 80 is the distance in yards that the golf ball travels. So I'll sketch that. And that's enough information to answer A, which shot travels further before hitting the ground. So we have shot number 1 and shot number 2. Shot number 1 from that diagram, it travels 100 yards. And shot number 2 travels 80 yards. So shot number 1 is greater, that travels further. Now we need to figure which travels higher. In shot number 1, they've already identified the vertex of this parabola, and one way to double check is that the vertex is going to be on the axis of symmetry, which is halfway between the two x-intercepts. So if we were to take 0 plus 100 divided by 2, we get 50, and that is the x value of the vertex, or that is the axis of symmetry. So I can fill in already for part B that shot number 1 had a maximum height of 25 yards, right? That's the y value, that's the maximum height. It happened at 50 yards into the ball traveling. It was 25 yards high. And shot number 2, well, I know that the vertex is going to be when x is 40, because if I add 80 plus 0 and divide by 2, I get 40. And then what I do is I plug 40 in to the function times 40, times 40 minus 80. And I get, cheating looking at my work from before, I get 32. So f of 40 equals 32. When x is 40, y is 32. So I can fill this in 32 yards high. And so the answer to B is shot number 2, travels higher. Again, this is the answer to part A, the answer to part B.